So hi guys, future achievers, welcome back to another lecture, and in this session we are going to discuss molality. Okay, I know it sounds similar to molality, but molality is different. Okay, now let's understand what is molality. Okay, first the definition of molality, let's read it. The definition is molality is the number of moles of solute per kilogram of solvent. Are you reading this? Solvent. Remember, can you tell me the definition of molarity? Molarity. The definition of molarity was number of solute per unit solution. So it was talking about solute, amount of solute present in the solution. Okay, but this thing is talking about amount of solute present in the solvent. Okay, now remember last time the solution, okay, the denominator part, okay, in case of molarity, let me just write this down, you will not get to know this. So molarity was what? It was number of solute. What is molality? It is also the number of solute. Okay, but in case of molarity, remember molarity, it was divided by volume of solution. Remember, solution. Okay, and in this case it is divided by the what is it is divided by what? Mass of solvent. Okay, mass of solvent. I hope you understand what is solute and what is solvent. When we add solute in the solvent, we get solution. Example 4, when we add salt in water, we get a salt solution. Understandable? So number of solute, okay, number of moles of solute. So number of moles of solute divided by the mass of the solvent. Understandable? Definition is clear, right? What is molarity? Number of solute moles divided by the volume of solution. What is molality? Number of solute moles divided by mass of solvent. This is the difference. Okay, this is the difference. Remember, molality is the only thing that discusses the concentration of solid with respect to solvent, not solution. Okay, I hope you are able to understand the definition, right? Okay, now just like the molarity, right? Okay, we have some different ways to write what is molality. Sometimes when people say one mole, a molar solution of this thing, okay, a semi-molar solution, a decimolar solution, a centimolar solution, a bimolar solution, you will like scratch your head and you will want to know what is this decimolar, centimolar. Okay, so whenever in any question there is written as molar solution, molar solution means 1 moles of solute in 1 kg of solvent. It means the value is 1. Okay, right? When somebody is saying semi-molar solution, semi-molar means 0.5 moles. Okay, 0.5 moles of solute per kg of the solvent. Decimolar means simple 0.1, centimolar 0.01, okay, bimolar 2. Okay, I think I have like taught you this particular thing in the molarity section itself. Okay, it's quite similar, right? This one shouldn't take any time. Okay, you just have to know semi means 0.5, deci means 0.1, centi means 0.01, and bimolar means 2m. Okay, it means 2 moles per kg of the solvent. Remember, it talks about solvent and not solute. Okay, I hope I am clear, right? Next question. Okay, we have a question. Now I hope before I start to do this question, you will pause the video and try to do it. Okay, so pause the video right now, try to attempt this question. Okay, I hope you have paused the video and try to attempt this question. Let's see if your answer and mine answer are same or not. Some people, they never pause the video. Okay, I hope you are not among them. Okay, now let's start. Question: calculate the molality of a solution. We have to calculate molality, not molarity. Don't confuse it. Molality of a solution containing 10 gram of glucose dissolved in 250 gram of water. Remember, here the water is solvent. Okay, what was molality? Let's write the definition of molality because it's the first question. Okay, now what is molality? Molality is, sir, number of solutes. Okay, number of solutes, what? Moles of solute. Okay, per kg of solvent. Okay, got it? Per unit mass of solvent. So how many moles of solute are there? So 10 gram is there, okay, and glucose. It means glucose is solute, right? And what is the mass of glucose? Tell me what is mass of glucose? 6 carbon, okay, 12 hydrogen, okay, and 6 oxygen again. Now what is this number? Tell me. 12, 6, 72, right? This 12, again 6, 6 means 6 ja 96. So this 2, 2 is 100 and 7, 10 is 180. This is the mass. How do you find out the moles of anything? Number of moles is equal to given mass upon molar mass, right, divided by the mass of the solvent. Okay, what is the mass of solvent, by the way? 250 gram. Should I write it 250? No, I should not write 250. I should write 0.250 kg. Okay, write it in terms of kg. Okay, now what is the given mass? Given mass is sir 10, sir molar mass is 180, and this is our answer. Okay, if you solve this particular thing, you will get an answer. So 0.25 is 440, so you will get 40 by 180, cancel, okay, 2 by 9, okay. So 2 by 9 is our answer. Okay, now you can just write it in terms of decimal, but we are not concerned with that. We are concerned with the way of understanding the situation. Okay, I hope it is pretty clear. Molarity, number of solute per kg of the solvent. Sometimes they will confuse and they will give you the weight of the solution. Okay, and remember, not the weight of the solution, weight of the solute. Okay, sorry, solvent. I am getting confused myself. Okay, now just like in case of molarity, if we are diluting something, what happens? What happens to molarity if we are diluting it? Answer yourself. Yes, the volume increases and the molarity decreases. But what will happen to molality if we are diluting it? If we are adding water, what happens to molality? Can you answer it? Okay, sir. If we are adding water in molality, okay, although the answer is written, but focus on yourself. Okay, if you are adding water, does it change the number of particles? Yes or no? Remember, molality remains unchanged during the dilution as it depends on the solvent's mass and not the solution's volume. Okay, so it means molarity remains unchanged. It remains unchanged until unless one of the factor is being changed. Remember, unless number of solute is changing. Is the number of solute changes in the dilution? No, it doesn't. Okay, does the mass of the solvent changes or not? Okay, remember, if your solvent is different and you are diluting it with some water content, okay, then it will not change. But if you are adding water itself and water is the solvent, it means the mass of solvent is increasing. If the mass of solvent is increasing, then in that case the molarity should change. Otherwise, molarity remains unchanged during the dilution as it depends upon the solvent's mass and not the solution's volume. Okay, got it? It depends upon the solvent's mass, not the solution's volume. But let's go on. Let's see what happens in case if there is a mixture. Okay, molality in case of mixture. Okay, we have solution 1 with some other molality, we have solution 2 with some other molality, and we try to mix it together. Okay, if you have seen my molarity question, okay, sorry, molarity question I am saying, if you have seen my molarity video, okay, this is the same formula that we study, right? M1 V1 equal to M2 V2, sorry, M1 V1 plus M2 V2 upon V1 plus V2 is equal to the molarity of the mixture, right? And this is the same exact formula. So if you are mixing two solutions, what will happen? Sir, the number of, if you are trying to find molarity of the mixture, right? Okay, what happens? Sir, the weight of the solvent gets added. Yes, very good. And what happens? The number of moles of the solid also gets added. Okay, and what is N1 equal to? N1 is equal to molarity into W1, the weight of the solvent in the first container, and M2 into weight of the solvent in the second container, right? This formula is as same as the molarity question. Okay, in this channel itself, okay, you will see one video where I have taught you about molarity itself. So if you saw that video, this video will be quite easy for you. Okay, it is just repeating content, so it's not something different. Okay, go watch that video and come back, and then you will feel that okay, this thing is very easy. Okay, Okay, where M1 and M2 are the molalities. See, M1, M2 are the molalities and W1, W2 are the weight of the solvents. In the previous molarity video, okay, instead of W1, W2, W1, W2, there was V1, V2, V1, V2, and those were the volume of solution. This is the weight of the mass, mass of the solvent. That was volume of solution. This is mass of solvent. Okay, remember the differences. And okay, we have a problem in here. 200 gram of 1 molar NaCl solution is mixed with 300 gram of 0.5 molar NaCl solution. Calculate the molarity of the resulting mixture. Let's calculate it. Okay, try to pause the video and do it yourself. It's very easy. Try to do it yourself, man. You can do it. So 200 gram, okay, W1 into M1 plus W2 into M2, right, upon W1 plus W2. Okay, so what is the answer? 200 into 1, 300.5, 150, 150 plus 200 is like 350. So 350 upon 500. Okay, you can cancel this out. This is like 7 by what, 10, right? 7 by 10, right? So that is 0.7. So answer is 0.7 molar solution. Okay, let's see some difference. That was very easy. So just understanding the concept is not very tough. Now, difference between the molarity and the molality. So what is molarity and what is molality? Okay, so molarity, it depends upon volume, but the molality, it doesn't depend upon, it depends upon mass, not volume. Okay, molarity, it changes with the temperature, and molality independent of temperature. Why? Can you think of the reason? Any reason you can think why molarity is dependent upon temperature, whereas molality is not? See, when you are changing temperature, the volume changes, hence the molarity changes. But when you are changing temperature, the amount of mass will not change, hence the molality is independent of the temperature. Okay, I hope you are able to understand the content of this particular lecture. Okay, till then, see ya, bye bye, keep studying, have a nice day.